You are about to enter the core of how data flows through the internet and cloud networks. Whether you're configuring a virtual network in Azure or troubleshooting connectivity issues, the basics remain the same. IP addressing, DNS, and routing form the foundation of all network communication. Let's break these down. When you connect a device to any network, it needs an IP address. This is its unique identity, like a digital home address. You'll come across two main versions: IPv4, which looks like 192.168.1.1, and IPv6, which appears as a longer format. You'll work with private IP addresses when setting up resources inside your internal network. These addresses, such as 10.0.0.1 or anything starting with 192.168, aren't routable on the internet. They're perfect for secure internal communication between your Azure VM subnets and services. On the other hand, public IP addresses are how your resources talk to the outside world. These IPs are globally unique and must be routable across the internet. If you are exposing a web app or a load balancer to users on the internet, this is the type of IP you'll assign. You'll also encounter CIDR notation like /24, which helps define subnet masks and tells you how many usable addresses you have within a range. It's a vital concept when designing scalable and efficient networks. In Azure, you have full control over assigning IPs. You can assign dynamic IPs, which may change over time, or static IPs, which stay consistent. Choosing the right one depends on whether your resource needs a permanent address or not. When you want to visit a website, you don't type in an IP address. You type in something easy to remember, like www.microsoft.com. Behind the scenes, DNS handles the translation of that name into a machine-friendly IP address, so your request can reach the right destination. DNS works like the internet's phone book. When you type a domain name, your computer sends a DNS query, usually to your ISP's DNS server or Azure DNS if you're in the cloud, to resolve the name to its corresponding IP address. To work confidently with DNS, you should understand the common record types. The A record is one of the most basic. It maps a domain name to an IPv4 address, allowing browsers to find a website hosted on traditional IPs like 192.0.2.1. The AAAA record is similar, but it maps to an IPv6 address. As the internet transitions to IPv6 for more capacity, this record becomes increasingly important. A CNAME record serves as an alias. It lets you point one domain name to another. For example, blog.example.com can point to example.wordpress.com without duplicating IP management. The MX record is used for email. It specifies the mail servers that should handle email sent to your domain. Without this, email delivery simply won't work. An NS record defines which DNS servers are authoritative for a domain. These are the servers that hold the actual DNS records for your domain and respond to lookups. In Azure, you can go even further. You can host custom DNS zones, configure private DNS for internal name resolution between virtual networks, and manage name resolution across hybrid environments. This level of control gives you flexibility, performance, and enhanced security in how you handle DNS inside your cloud architecture. Once the IP address is known, your data still needs a way to reach the right destination. And that's where routing comes into play. You can think of it as a GPS for your data packets, helping them find the most efficient path across networks. Every device you manage in a network uses a routing table. This table contains a set of rules that determine where traffic should go based on the destination IP address. If there's no exact match, it looks for the next best route or default gateway. You'll work with static routing when you want full manual control. With static routes, you define exactly where traffic should go. This can be helpful in small controlled environments where routes don't change often and predictability is key. On the other hand, dynamic routing lets routers handle the route discovery for you. Routers share information with each other and automatically adjust their paths using protocols like BGP. This is essential for larger networks or when connections change frequently. In Azure, you can take this a step further using user-defined routes. UDRs let you customize how traffic flows within and across virtual networks. You can route traffic through appliances like firewalls, control hybrid connectivity, and even override system routes. You also have the option to peer VNets or extend your network securely using VPN gateways or express route, giving you enterprise level flexibility. So, when you ping a website, here's what happens behind the scenes. Your machine checks its local DNS cache. If not found, it queries a DNS server to get the IP. The router checks its route table and forwards the packet. The packet travels hop by hop until it reaches the destination. A response comes back and you see the web page. Understanding this flow empowers you to troubleshoot faster, design networks smarter, and configure Azure resources more confidently. So, what's your key takeaway? By now, you've laid the groundwork for your networking journey. You understand IP addressing, DNS lookups, and routing decisions. Three pillars that support all modern networking, whether in a data center, your home, or the Azure cloud. In the next lectures, you will build on this by learning how to configure VNets, subnets, firewalls, and hybrid connections. But it all starts here, with knowing how machines talk to each other.